Student, very good morning, good afternoon and good evening one and all present here. In this video, I will discuss the periodic functions, the examples and related graphs, real life examples, calculation of period and application to definite integral. This video is a very short period and the fastest conceptual clarity leading to the graphs and its application. Now, a function is said to be periodic. A function is said to be periodic if there exists a small number, positive number, such that f of x plus t is equal to fx for all x belongs to domain of f, where t is the smallest positive number. Let us look to the here all trigonometric functions are periodic functions. Let us see sin x. Sin x 0 to 2 pi, 2 pi to 4 pi. What do you see here? The sin x plus 2 pi, sin x plus 4 pi, they are all equal to sin x. So 2 pi, 4 pi, among them the smallest one is 2 pi. What is the period? Period is 2 pi. What we see? This length is called the period and it is called one cycle. Here the shape of the curve remains same or the orientation remains same. It moves horizontally and it exhibits translational symmetry. You can say the examples in physics, electromagnetic waves, radio waves and light waves. Now this is one cycle and the length is and the shape is repeated, and you come to cos x plus 2 pi. Here you will see this period 2 pi and cos x plus 2 pi is equal to cos x plus 4 pi up to cos x. So among the t, who is the smallest? 2 pi. So period of cos x is 2 pi. Coming to tan. Tan is not defined at pi by 2. So it is asymptote and we draw it, and what you see, this length is pi. So tan of x plus pi and tan of x plus 2 pi up to tan of x. Among them pi, 2 pi. So who is the smallest? The pi. The period of tan is pi. Similarly, the cot, period of cot of is pi. Now, coming to the functions and period, a list of functions and the periods I have given here. All the trigonometric functions sin x to the power n, cos x to the power n, sec x to the power n, cosec x to the power n is equal to 2 pi for n is equal to odd. That is sin x cube, sin x to the power 5. Similarly, sin square x, cos square x, it will be even pi. And tan x to the power n, cot x to the power n is equal to pi for n is equal to odd or even. And mod of sin x, mod of cos x, you can say that mod of p of x, 6 trigonometric function, the period is pi. And mod of sin x plus mod of cos x, mod of tan x plus mod of cot x, mod of sec x plus mod of cosec x, all their period is pi by 2. Now, if fx has a period t, then 1 by fx and under root fx has period t. Now coming to, if fx has period t, then f of x plus or minus b plus c has period also t. If fx has period t, then f of ax plus b has period t by mod a. Now, if we discuss certain problem, if fx is a function is periodic with t, gx is periodic with t, then it doesn't mean that fx plus gx need be periodic. Now take for example, fx is equal to sin 2x plus smallest integer x integral. Then period of sin 2x is 2 pi by 2 is pi, which is irrational, and period of the fractional part of x is 1. And LCM of pi and 1 not possible because pi is irrational and 1 is rational. So we see that. And also it doesn't mean that if fx and gx have the same period, mod of sin x, mod of cos x. What do you see? Mod of sin x is pi and mod of cos x is pi. But it does not exhibit the period is pi because it can be changed. If x plus pi by 2 is mod of sin x and mod of cos x. So pi by 2. In the formula list I have given it. Now coming to applications, sin x 4 and sin x to the 4 and cos x to the 4, that is sin square x plus cos square whole square minus 2 sin square x square. So simplifying, we get it 1 minus 1 by 2 sin square 2x, 1 minus 1 by 4, and sin square 2x converting to 1 minus cos 4x. Now simplifying, we get this one. Now we want the period. The period determines this 4, and we get 2 pi by 4 is pi by 2. So the period of this function sin x to the power 4 plus cos x to the power 4 is pi by 2. Now coming to a very important question, that is sin pi x by n minus 1 factorial plus cos pi x by n factorial. Then what is the period of this function? 2 pi by pi n minus 1 factorial, simplified 2 into n minus 1 factorial. And what is the period of this one? 2 pi by n factorial, and is coming out 2n factorial. What is the LCM of these two? Is 2n factorial. Fantastic question. And now fx is e to the log sin x plus tan cube x minus cosec 3x minus 5. What is the period of this one? 2 pi. What is the period of pi? What is the period of this one? Coefficient divided 2. So what is the LCM of these three? Is 2 pi. Now coming to the greatest function, fx is sum of greatest integer x, greatest integer 2x, greatest integer 3x. Like this is continuous up to greatest integer nx. What is the period of this one? Is 1. 1 by 2 dot up to 1 by n. What is the LCM of this one? Is 1. Now let us come to definite integral application. 0 to 10 pi modulus function sin x dx. You know that modulus sin x is period is pi. So from the upper limit we keep the safe in one cycle, that is here the cycle is pi, the length of the cycle is pi, 10 is taken common. That is the properties of the periodic function. And mod of sin x 0 to pi, sin x is positive. So I leave the modulus sin, and sin x 0 to pi is 2, so 10, 20. And now coming to 0 to 100, x minus greatest integer x, that is fractional x, and the period is 1. So I keep the period, one period. And because the period is repeated, here the period is repeated. How many times the period is repeated? 100. How many times the period is repeated? Is 10. So I 100 taken common and spread it. 100, 0 to 1, x dx. And this is 0 because 0 to 1 greatest integer is 0. And 100 into x square by 2, that is 1 by 2, 50. So this comes to an end of my video. And it's a very important concept. The periodic functions, examples, the graphs. And particularly we need it to draw the graphs, and it is in calculus this is the most important. So please see this video up to the end, and thank you, and have a nice day.